just reading on the commentary, you really have to have all the conditions here. Now, the mean value theorem, let's first do that one. Okay, the mean value theorem says that if I have a function and it's continuous and it's differentiable, f of x must be continuous and differentiable. Oops. So they talk about this when I read the commentary saying, you need to make that statement that the function's continuous and differentiable to apply the mean value theorem. Because if it's not, it doesn't apply. So it seems kind of crazy, but you have to be that picky about it. But yes, you do. I was reading the commentary. And the mean value theorem just says that if I have endpoints A and B, oh, it also has to be on a closed interval, that there's some value in here, C, such that the slope of the tangent line is equal to the slope of the secant line. That's all it says. And I think they'll ask you a direct question. We're going to do 2007. So f prime of C is equal to the slope of the secant line, f of B minus f of A over B minus A. And we remember that the derivative is an instantaneous rate of change. So what is the right side? That slope there. It's not an instantaneous rate of change, it's a, got to know this, average rate of change. F of B minus F of A over B minus A is the average rate of change. That's because that's what the theorem says. That there is some place on that interval between A and B such that if I draw the tangent line, it will have the same slope as the secant line. So in other words, the instantaneous rate of change equals the average rate of change. If my average rate of change is 50 miles per hour, then that means I was driving 50 miles per hour. And they could ask you a question like that, just like that on the exam. Okay, the intermediate value theorem, we'll do that. That's what we're going to go next. This is MVT. Now, I was looking through the commentary. I think if you're going to use the mean value theorem or intermediate value theorem, you better write it down. You do have to say, because the function's continuous and it's on a closed interval, it's differentiable everywhere, no problem. The intermediate value theorem says that if I have a continuous function on a closed interval, just was thinking, make sure it was closed. Then, let me draw a picture. I think that's the easiest way. You pick a function. I'll make this a simple function. Here's A. Here's B. So here's f of A. And here's f of B. And all the intermediate value theorem says is that if you have a closed interval of a continuous function, that if my function hits this value, f of A, and then goes to f of B, it hits all values in between them. So if this were 2 and this were 10, my function would pick up all values between 2 and 10. Think of temperature. If it's below 0 and then it gets to be above 0, it had to be 0 someplace. No, it didn't say where that happens. It just says it has to happen. And where it happens, there'll be some sort of C. So f of C will be between f of B and f of A. Yeah. It could. I did a simple function. The fact that it's somewhere on my interval, I don't know what it's doing in between, and it goes from 2 to 10, it means it has to have hit 8. It won't have hit 1. It doesn't mean it won't hit 12. It just means that I guarantee this. This is a guarantee. Okay? And I have a continuous function on a closed interval. Ready? We're going to do 2007, number 3. Both of these concepts are in that problem. Yeah. Just tonight. Tonight, review 6 to 9 o'clock. Hersman's room. Whatever you guys want to work on. Yeah. And then tomorrow during class, we'll do the practice AP test, so to speak, 2 free response questions. It will be timed, and we'll grade it in class. And then other things just to calm you down a little bit. AB. Tonight's AB and BC, but 1404, Hersman's room. And depending on how many BC kids come, you can come down here and work. A lot of people do that. And 60% of the exam is, for the BC students, is AB topics, so they got to know how to do it. So they need to review the AB topics as well. Okay, you ready to do 2007? That's what we did this morning. See if you can do it again. Yeah. Well, first off, the chart's a little bit intimidating. I think it is. Okay, what are we going to do with all that information? So you're going to slow down, you're going to relax a little bit, take a deep breath, and read. It says functions f and g are differentiable. Remember, I said to use these theorems, they have to be differentiable for all real values, all real numbers, and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. Now, h is this function. It's a composite function. So h of x is equal to f of g of x minus 6. Explain why there must be a value, r, we'll call it r, you could call it c, you could call it anything they want, between 1 and 3 such that the value of the function at that r value is -5. And that's the intermediate value theorem. We'll slide this down. So how do you do that? It says, I know that someplace on my interval between 1 and 3, h of r has to be equal to -5. What if I found out what h of 3 is and h of 1? Then I could show, well, prove or disprove either way. So h of 3 is f of g of 3 minus 6. And h of 1 is, and this is going to come back and haunt us. We're going to use this in part B too. F of g of 1, minus 6. And then you use your little table. Not too bad. What's g of 3? G of 3 is 4. So this is equal to f of 4 minus 6. And f of 4 is -1. So this is -1 minus 6, or -7. Well, that's good. If my next value is like -4 or bigger, I'm okay. So what's g of 1? G of 1 is 2 minus 6. So what's f of 2? F of 2 is 9. 9 minus 6, which is 3. Since my function is continuous and differentiable, it goes from -3 to +3. Clearly, it goes through -5 by the intermediate value theorem. Last class said, do I have to write that? I think you better. Yeah, you can write just the way I did. Yes, but you also have to say that your function is continuous. No. So when I read that summary of that, they said the kids didn't do that. Wish I'd read it before class, other class. So the next one, I have a derivative between 1 and 3. You could calculate it using slope formula. So what's true about the slope? H prime of c, which is equal to -5, is going to be h of 3 minus h of 1 all over 3 minus 1. This is the mean value theorem. Isn't Because it says that the instantaneous rate of change is equal to the average rate of change. So that's where there has to be value there. And it wasn't multiple choice questions, too. So what's h of 3? Oh, I already did this. H of 3 is right here. Negative 7 minus h of 1 is 3 over 2. So is that equal to negative 5? Yes. They're not going to try and trick you and make you test every value there. Take too long. So they're going to give you the endpoints. What about C? I love that problem. It's the fundamental theorem of calculus. Part 2. It asks for w prime of 3. Well, if w is equal to this integral. Okay. But just because you couldn't do A and B didn't mean you can't do C, because you can. And I want w prime of 3. Well, what's w prime? I'm just going to take the derivative with respect to x of everything up here. Well, what's the derivative of an antiderivative? This is the function back again. But don't forget the chain rule. Remember the chain rule on that one? Remember, the derivative undoes the integral. They cancel each other out. And so you get f of, remember, you put this in here, f of g of x times, because if you were to integrate this, you would have some function of g of x. So when you differentiate that, you have to take into account the chain rule. So it's times what? G prime of x. Well, what is that? Now this is at 3. So this is equal to f of g of 3 times g prime of 3. What's g of 3? Oopsie. G of 3 is 4 times g prime of 3. What's f of 4? F of 4 is negative 1. What's g prime of 3? G prime of 3 is 3. The average score on this one was not very good. We can look at it. So that wasn't hard. But, you know, you've kind of been beat upon on A and B, and then they like to kick you when you're down. Because what's the antiderivative of my function evaluated at 1? It's a constant, and the derivative of the constant is 0. Remember, we've had this formula before. We need to know that. Well, I don't know how to antidifferentiate f of t because I don't have a function anyway. So I can't. I just know it's a constant. Okay, you ready? Yeah. I want the equation of the tangent line here at x equals 2. So if x equals 2, then this is g inverse of 2. Look at your table. What is that? Why do I care? Because I'm going to do y minus y1 equals m x minus x1. I have my x's, I need my y's. Now remember, that's the inverse. So if g inverse of 2 is equal to what? 1. So you get a point for knowing that. But they're saying g of y is equal to x. X is equal to 2. What would that be? It would be 1. I have a hard time with that, too. This is the x value. Remember, g will be 2. Wait a minute, no. G is 1 comma 2, right? If I look at my table, there's 1, comma 2. What if I do the inverse then? What's this point on the inverse? 2, comma 1. It wouldn't make sense for this to be 2 and that to be 2. It doesn't make sense. So there's another way to do it. So y minus 1 equals my slope, x minus 2. I'm pressed for time. I probably would leave my answer and go on to the next problem. The g function is 1 and 2. What's its inverse? 2 and 1. Just switch them. Because it says x is 2. And I want g inverse, not g. It's hard. Because it's this. It's g inverse of 2. Which means that g of x is equal to 2. What's the x value for that? Look at your chart. What's the x value? It's 1. So when I do the inverse, right? X equals 1. So if I do g inverse, I have to switch the 2 and the 1. I'm not going to use y because of the fact that, or f of x, because there is an f of x and it's not the same thing. So we're just going to call it g inverse. Because I have to find the slope. I need to find the derivative of the inverse function. And I don't know what g is. Oops, it's supposed to be a g. Sorry. And I don't know what g is. So I have to do it the other way, the hard way. That's what I want. So, what I'm going to do is this. G of g inverse, rather than calling it f of x and everything, because it'll be easier to keep it straight, is equal to x. So that makes sense. If I take a function and I take its inverse, I put them together, they undo each other. And now let's take the derivative. And if I try it with g inverse of g of x, it'll just fail for me. So I'll go, oh, I'm going to switch them. So what is the derivative of that? It's the derivative of the outer function times the derivative of the inner function, which is what I'm trying to find. I'll write it that way because I'm going to get confused with the primes. I know they do it both with the primes, but I still get confused. It's equal to 1. So what is the derivative with respect to x of g inverse of x? It's equal to 1 over the derivative, oh, this is inverse, sorry, g prime of the inverse of x. That's sloppy. Let me fix that. And it's important to keep it neat. I think so. We'll find out. Now you can memorize it. That's fine. X is equal to 2, because that's what they said. So it's 1 over g prime, g inverse of 2. What's the coordinate that goes with the g inverse of 2? That's 1. So it's equal to 1 over g prime of 1. And I know the answer, but I'm going to go back and look. What am I looking for? G prime of 1. And g prime of 1 is 5. Kind of a nasty problem. And that's your slope. Go back up somewhere. Up there. You have to go back to this and take the derivative. I work it out every time because I get confused as to which number I want in there. Right there. Look at scoring. Okay. Notice they use the word intermediate value. So you can do IVT, it's fine. You have a continuous function. Here I have a continuous and differentiable function on the mean value theorem, but you should talk about that. There's my derivative of my antiderivative, 2 points. So I get 6 points right there. The last one is worth 3, but or the last one. There it is. 1 point for finding the ordered pair 1, 2. That to me is the tricky part. 1 point for finding the derivative, and then 1 point for the tangent line. So it's not even worth doing the tangent line. It's only 1 point. I messed it up. So don't put a lot of time into it. Now, the other class, we did a whole bunch of other problems from this particular exam year. It's up to you, or you can just work on your own and ask me questions. It'll work. 2 days. Okay. Well, but you don't have. You can't take the derivative. But it says to what? It says to estimate, right? Can't you just find the slope between these 2 points? Can't you just take 5 minus? Whoops. I almost goofed it up. The change in y's is 4 minus a negative 2 over 3 minus 5. So that's 6, negative 6 halves, or negative 3. Now, you guys, you won't get the point for the negative 3 unless you show the work that I just did. There it is, and it's 1 point. But even if you just have the answer, you're not going to get the 1 point. You got to show the work. Okay. Okay, now it says evaluate that integral. That's not bad, is it? Are you having problems with the? Let's see. What? Ask me. Well, I don't know what you're saying. The regular Riemann sum is a rectangle. Do we have a Riemann sum here? We'll do that. Okay, so first thing, show that word leads to your answer. Evaluate that integral. Well, that's just what? That's equal to the integral from 2 to 13 of 3 dx plus, or actually minus, the integral of 5 f prime of x dx from 2 to 13. So what's this going to be? That's just a horizontal line. That's y equals 3 from 2 to 13. Just use geometry. You can integrate if you want, but it's really 3 times 13 minus 2. Now what about this one? Pulling the 5 out, what's the antiderivative of f prime of x dx? F of x. Using the fundamental term of calculus. Let's see, this is going to be 33 minus 5, and then this is going to be f of x evaluated at 13 minus f of x evaluated at 2. Do I have that? Oh, f of 13 is what? 6. So it's 33 minus 5, and that's 6 minus, and what's f of 2? Gotta go back up again. F of 2 is 1. Just watch your signs. That's about all I'd say on that. So it's 33 minus, and 5 times 5 is 25. So the answer is 8. Let's check that one. Maybe. Okay. Still not a lot of points. It's 2. Using your fundamental theorem of calculus, the fact that you set it up to do that, saying I have to integrate that, even if you don't know what to do, it's there. And then 1 point for the answer. Okay, what's the next question? No, we're doing C. Use a left Riemann sums with subintervals indicated by the data in the table to approximate 2 to 13. Make sure you read this carefully, because I've done this where I looked at the whole thing and said, this doesn't work, it doesn't fit, because it wasn't 2 to 13, it was like 3 to 8, but this is 2 to 13. So make sure you read the problem. And so Riemann sum is just finding the area of the rectangle times the height. So there's the height, which is 1, and I want a left Riemann sum, so I want the left side, so it's times 1, plus, and then I'll do the next interval. How big is that one? 2, and I want f of x on the left side, so it's 4. Then what's the height here? I don't have any room. Plus 5 to 8 is 3 times the height. -2 or 3, which one is it? -2 plus, and the very last one, that's 5. And hitting on the left side is 3. $18? Is that right? Okay, so it's 18. What are we trying to find? And, is that it? Oh, that didn't even ask me to interpret it. That's nice. As long as you have your left Riemann sum there, it's okay. Some of you prefer to draw it. Pardon? Yes, as long as you know your work. But, good point. Put it in your copy of your exam that we read. Don't put it on the green or the blue sheet. We won't ever look at it. Yeah, we won't look at the green and blue sheets. We don't see those. We just see your test copy, your test little booklet. Okay, so we are now at a 5 points. So far, it really hasn't been that bad, at least I don't think. And then, what's the next one? Suppose, now this one's tricky. Suppose that the first derivative is 3 and the second derivative is negative. The second derivative is negative. This means it's concave down. This is between 5 and 8. Use the tangent line to the graph at x equals 5 to show that f of 7 is bigger than 4. Use your tangent line graph at x equals 5 to show that f of 7 is less than or equal to 4. So what is f of 5? That's the 4? -2. Okay. So the tangent line there is going to be y minus or plus 2 is equal to my slope, which is 3, and it's x minus 5. You do the mean diagram on this? Because it says x equals 5, so I went back up to my chart. And it says f of x is -2. Now, f of 7 is the real value. If it's concave down, and you're doing a tangent line, here is the tangent line approximation right there. Is basically they're asking, is the tangent line an overestimate or underestimate? The real value is below this, because it's concave down. You see that or not? That's what they're asking. Was the way the question's framed was bad. Okay. The equation of the tangent line, I did that. So you get that. And it says it's concave down. Then the line tangent of the graph lies above the graph. And you can talk about the concavity to do that. So I did do it right. Nice. All you have to do is write the equation of the tangent line. And then you have to look at the second derivative. It's concave down, so you draw your picture here and say, oh, you say, see, it's bigger, or whatever, the other one's smaller. You use the secant line for the graph to show that the value of the function is bigger than 4/3. Now, what's the secant line? 7. So we're going to do the secant between 5 and 8. So here would be 5. Something like that. Oopsie. So it would be this secant line. Let me draw a better picture. The secant line is this. If this is 5 and this is 8, what would have to be true about 7? The secant line is underneath it. So the f of x is bigger than the secant line. And that would be f of, what, 7/4? What did they give me? No, sorry, I'm saying that wrong. And it says f of 7 is bigger than 4/3. So I know that f of 7 is bigger than my slope of my secant line. How do I find the slope of the secant line? Because that's what I have to figure out. It's the same as that 2007 problem. So I have to do f of 8 minus f of 5 over 8 minus 5. And I have those values, right? What's f of 8? 3 minus f of 5 is -2. And that's 3. Why do I feel like I'm doing it wrong? 5/3. I just have to show that's the slope of the secant line. F of 7 is bigger than 4/3. And I know that f of 7 is bigger than 5/3. I do a calculation wrong? Do it right? Let's see. So I wrote the equation of that line, and it says, oh, you have to plug it in here. I'm getting the last point. That's what I was thinking. Oh, they plugged it. They wrote the equation for the secant line. Oh, they actually put, yeah, I agree. I think I'm just reasoning it out. They actually found the equation of the secant line. And the equation of the secant line is y minus y1 equals my slope of 5/3, x minus x1. And we're doing this where? Minus. Oh, it doesn't matter. It doesn't make any difference which one I do. And then what's the y value there for 5? -2. So solving for y is equal to -2 plus 5/3 x minus 5. And if you put in 7, because that's what they want you to do, is find f of 7. I want to compare it to that. So x is equal to 7. Y is equal to -2 plus 5/3. And 7 minus 5 is 2. And that should be equal to my 4/3. I think it would be sufficient if you wanted to argue it. But the slope of the secant line is going to be 5/3. Well, maybe not. I think you have to write the equation of the secant line. Why don't you explain it? No. But you have to actually look at f of 7. Oh, we don't have time for another one, do we? Just, okay, but you know what? When you're looking at this, okay, it takes you 20 minutes. So you're not going to get through the whole thing, but you can get through this one. You can get through this one. So you're at 5 points right away. Then this got a little trickier. Actually, they found the value. I think the way I argued it was fine, too. They actually found the value. So find the value using the tangent line. And the secant line. Who's going to be missing tomorrow? Anybody?